Welcome all viewers and dear students. Today we have a new topic, increasing function. What is increasing function and decreasing function? And decreasing function. Dear students, increasing function we are two definition. The first in the comparison of the two function if we are doing. So for example, a function is strictly increasing over the interval a over b if condition is applied here f of x1 is less than f of x2 when x1 is less than x2 and x1 x2 belongs to the interval of a or b. Here x1 value must be less than x2 and their function also must be less than x2. So increasing function. Graphically we draw that is x-axis, origin and y dash. These are the 2 points a or b. So f of x1 is less than, f of x1 is that point, f of x1 means here x1 we give the name x1 and here x2, that is x1 and x2 belongs to this number, and f of x1 or f of a must be less than of this function. If we give the name f of x2, that is or f of b. So f of x1 must be less than of that point, that is f of x2 or f of b. So the function if we are making here, so the function is on that type, means from the function is strictly increasing from left to right. Or another definition we can use here, any function f of x is said to be increasing f dash x is greater than 0 or dy by dx is greater than 0 over the interval, and the graph of this function goes up from left to right, from left to, that is left from to right, from left to right over the interval a or b. So that is called increasing function. Similarly, if we are defined decreasing function, no a function is strictly decreasing, just we change here some points here, decreasing over the interval, a or b, and f of x1 is greater than f of x2. Here this point must be greater here. Now the graph is also changed here. F of x1 is must be greater than f of x2 when x1 is also greater than x2, and x1 x2 belong to this number. Look here, f of x1, that is point is f of x1 or f of a, that point. And similarly, if we decrease that point to from here to that point, f of x2 or f of b, so that time from left to right is also decreasing on that point. Another definition, f of x is said to be decreasing if f of dash is less than 0 and dy or dy by dx less than 0. So the graph of this function goes down here. Just change this number down from left to right over the interval. That is the slight change in the definition of increasing and decreasing function. Note that point, when any function f of x is said to be neither increasing nor decreasing, neither increasing nor decreasing. What is the situation? Note that point, when any function f of x said to be neither increasing nor decreasing, when dy by dx is equal to 0 or f of dash x is equal to 0, and this situation the function will be neither increasing nor decreasing. But graphically they will be a straight line. But graphically we get a straight line. Neither increasing nor decreasing, that is y and y dash and x dash. If we draw any line which must be constant, for example we draw, so the function lies, that is called constant. That value is so such because there is neither increasing nor decreasing. If we are finding the derivative of this function, so the result will be equal to 0 or f dash is equal to 0. So that type of function is called constant function, and the result will be called neither increasing nor decreasing. maximum function. There are two conditions we are applying. In the maximum function, the first derivative must be equal to 0, and the second condition, if double derivatives double dash is less than 0. And this situation we are called maximum function. So any function f of x is said to be maximum function at specific point x is equal to c. xc is called specific point. So we apply the two conditions. Two conditions. The first condition we are applying dy by dx or f dash x is equal to 0. Both must be 0. And the second condition we are applying double derivative dx square or f double dash prime x less than 0. Less than 0. So that is called maximum function. The point where we find the point where the function is maximum. Maximum is called maxima. Maxima. That is called maxima. Where we find the point from the above function, so we get the maximum function, that is called maxima. And another for the minimum function. Minimum function. Minimum function, any function f of x is said to be minimum function at specific value at x is equal to c. So we apply again two conditions. The first condition is 0 and the second condition must be greater than 0. Greater than 0. So that is called minimum function. And the point where the function is minimum, and that is called minima. Minima. What is concavity? Any function of that property, we use the property of any function f of x which is either concave up and that type, that is concave up, or concave down, or concave down, and that type of curve concave down is called concavity. So that is called concavity. Points of inflection. What is point of inflection? All the points of the concavity, concavity downward or concavity upward, from from upward to downward or downward to upward, this changes is called point of inflection. All the points, we write the definition here, all the points of the concavity of the graph of the function, change from upward to downward, or downward to upward. All the points, where the points, if we change the concavity means here if they are going on the and that type concavity down or concavity upward, so the direction of this type of function. So for example, this is A and here B and C, downward, upward E and E up to so on F. So that type of concavity, they are increasing and also decreasing of that point is called point of inflection. All the points where they are from changing from upward to downward, upward to downward, upward to downward, and that type of situation is called point of inflection. So second derivative test, another is second derivative test. That is very important. We are using second derivative test for the relative minimum or relative maximum. So when f dash is equal to 0 and the second derivative, if we test, is greater than 0, and that type of first derivative second derivative test, so the function, this will be a relative minimum, a relative minimum function. If the second condition, when f dash x is equal to 0 and the second derivative f double dash x is less than 0, so the function is a relative maximum. That point must be noted for the second derivative test. Thank you very much for watching. Please subscribe my channel and share this video with your friends. Once again, thanks for watching.